A function f is a rule that assigns to each element x in the set A exactly one element called f of x in the set B. So set A here is called the domain. And the set B here is the set of range. So how does that look? So let's say you have a set A, here's the domain, with this value A, B, C. And you have another set B with the value of 1, 2, 3. This function, this is the function if each element in set A get assigned to exactly one element in set B. That is an example of a function. You can have a function like this, A, B, with the set A, B, C. You can have that. So here that you can say each element in set A assigned to one element in set B. So here's an example that is not a function. So as you can see here, A is assigned to both 1 and 2. Therefore, this is not a function. Okay. The set A and B are set of real number. The set A is called the domain of the function and the set B is called the range of the function. F is equal to f of x where every x is come from set A. It is helpful to think of x as an input and f of x as an output. So let's think of every element in set A as an input and every element in set B as an output. Okay. So express the function f of x equals x to the third plus 2x inverse, then evaluate the function at the indicated value. So the inverse here, f of x, is a function in which it takes the input x cube it then add twice the input. Okay. So let's evaluate this function at each of the input value. So f of negative 2 is equal to negative 2 to the third plus 2 times negative 2. And that is negative 8 minus 4 make negative 12. F of 5 is equal to 5 to the third plus 2 times 5. That is 125 plus 10. That makes 135. F of A. The input now is A. So we take the input, cube it, then add twice the input. F of A plus 8. You take the input, cube it, plus twice the input. So let's expand this out and then combine later. So since there is no like term in that case, we will just leave it at the expanded form. Evaluate the piecewise defined function at the indicated value. So if the value of x is less than 0, then the function is f of x equal to x squared. If the value of x is greater than or equal to 0, then the value of the function is the line x plus 1. So first, f of negative 2. This means it is less than 0. So negative 2 squared equals 4. F of negative 1, that is negative 1 squared, that equals 1. F of 0 equals 0 plus 1, that makes 1. F of 1 equals 1 plus 1, that equals 2. And f of 2 is equal to 2 plus 1, that makes 3. In the next function, we want to find f of 2x. 2 of f of x squared, and f of x quantity squared. So here note that if you have the value multiplied in the input, it is different as the value multiplied with the output. If you square the input, the answer is different as squaring of the output. So keep that in mind. So note that f of a times x is not the same as a times f of x. F of x to the power n is not the same as f of x together to the power of n. So keep that in mind. The net chain. The net chain in the value of the function f as the input chain from a to b, where a is less than or equal to b is given by f of b minus f of a. The net chain can be positive, negative, or 0. So for example, we want to find the net chain in the value of the function between the input f of x equal to t squared, f of t equal to t squared plus 5t from negative 2 to 5. First, we calculate f of 5. Next, f of negative 2. So the net chain here is equal to 50 minus negative 6. And that is 56. So let's talk a little bit more about the net chain. So you have a function. It's got to look like this. We're talking the net chain overall, talking about how much changing in the y direction did it go in overall. You can also have the function kind of look like in this case. So the changing in the direction from A to B, well, you start at the same spot, start at one spot, and kind of end up at the same spot on the x-axis. So the net change here in this case is really just 0, right? So the net change again is just talking about how much changing is it in the y direction.